Good afternoon. This is your tutor of Policing Mathematics. My contact details are displayed on your screen so that you can always contact me whenever you have difficulties doing your mathematics assignment. Our mathematics, the level at which we are doing the mathematics, is based on a level between grade 10 and 12, or ordinary level in the Namibian curriculum. And the basis thereof then, it should be such that when doing revisions or going through our assignments, we should also be able to contact teachers or learners or students that went through the mathematics curriculum between grade 10 and 12 levels as well, because they could also assist us whenever we get stuck in doing our assignment. Now, in terms of the learning outcome, expected learning outcomes, we should be able to, at the end or through the course that we are taking, Policing Mathematics that is, we should be able to do calculations that involves positive and negative numbers. We should be able to use the calculator correctly whenever we are doing calculations. Added to that, we should be able to solve equations as well as indices correctly. We should be able to convert between different units, for example, from kilograms to grams, or alternatively from kilometers to meters and vice versa. We should be able to plot and draw graphs correctly, being it bar charts or bar graphs or line graphs and so on. So we should be able to do that correctly. We should be able to define and estimate the sizes of circles, angles, as well as triangles correctly. So those are where the expected learning outcomes. If what our focus is, we will deal with the topic of fractions. What is a fraction? A fraction is a part of a whole thing. It's a section, it's a portion of a whole thing. So that is the definition of a fraction. Now, in terms of our course, we should be able to add and subtract fractions correctly. That's the first one. Secondly, we should be able to determine the numerator and the denominator and be able to do addition, subtraction, multiplication, and divisions of fractions without making a mistake. Now, today, the first focus will be on the addition of fractions. Suppose we are given the fraction that is now on our display, which is 1 over 2 plus 2 over 3. Now, these are two fractions that we are looking at. The top part of any fraction is called the numerator, and the bottom part is called the denominator. Now, for us to add or to subtract two fractions, the denominators should be the same. But in this instance now, our denominators are not the same, so we need to make them the same by looking for what is referred to as the LCM, or in other words, the lowest common multiple. So then the LCM of 2 and 3 is 6. Now then comes the question of, how did you know that is the LCM? One of the most basic methods that we were taught in primary school is for us to count in terms of the multiples of 2. Then we'll count like 2, 4, 6, 8, and the pattern continues. And in terms of the multiples of 3, it will be 3, 6, 9, 12, and the pattern continues. So now the LCM would be the smallest number that is in both lists of multiples, because the first line gives us the multiples of 2, whereas the second line gives us the multiples of 6. So therefore, the smallest or the lowest multiple, which is common in both, is 6. So therefore, the LCM is 6. So that then means that we need to find equivalent fractions for both these two fractions that would have a denominator of 6. So going forward then, we will end up with 3 over 6 plus 4 over 6. So now seeing that both our denominators are now the same, whenever we add fractions, the denominators should first be made the same. Now that they are the same, we only add the numerators. Since the denominators are the same, we only add the numerators, and that will then give us an answer of 3 plus 4 is equals to 7 over 6. So that is then the expected answer. And for now, we can leave our fraction as an improper fraction. We don't have to convert it into a decimal fraction or anything else. Now let's look at the second one, B. Looking at the second fraction, we have 3 into 1 over 4 minus 1 over 5. Here we are now to deal with the subtraction of fractions. Now, in the subtraction of fractions, what we are also looking at here is that the denominators once again are not the same. And the prerequisite is that both denominators should be the same in order for us to be able to solve the problem or to subtract the two fractions correctly. So, but now the first challenge that we are faced with is that the first part there is not necessarily a fraction, it is called a mixed number, because we have 3 into 1 over 4. So we need to convert this into an improper fraction. But how do we do that? We always take the number in front here, we multiply it by the denominator, and then we add the numerator. So in this case it will be 3 multiplied by 4, which is 12, plus 1, it will be 13. So as a fraction, 3 into 1 over 4 is equivalent, or it's equals to 13 over 4. So therefore, our first step then would be 13 over 4 minus 1 over 5. But again here, we should then remember that our denominators are not the same. We need to look for the LCM of 5 and 4. The LCM, or the lowest common multiple of 5 and 4, is 20. So in this case, our LCM is 20. If you don't know how to get the LCM, write down the multiples of 4 as well as the multiples of 5. After which, then we will be able to identify 20 as the lowest common multiple of the two. So now in terms of 20, so we will then have the fraction of 4 multiplied by 5 gives us 20. So on top we will have 5 multiplied by 13. 5 multiplied by 13, and that is 65. On top there, minus 4 over 20. So now that then would be equated to 65 minus the 4, it is equals to 61 over 20. So that is our fraction. We don't have to express it as a mixed number or anything. That is good enough if we leave it that way. That's now the fraction in terms of having the same denominator that became 20, and then subtracting the numerators, it produces that. Now we will quickly look at the multiplication of fractions. Now, in terms of the multiplication of fractions, we will look at the fraction 3 over 4. 3 over 4 multiplied by 2 over 3. as a starting point. When we deal with multiplication of fractions, we multiply the numerator with the numerator, and then we also multiply the denominator with the denominator. We don't have to make the denominators the same. The LCM, or the condition of making the denominators the same, is only applicable to addition as well as the subtraction of fractions. So in this case then, we will have 3 multiplied by 2 divided by 4 multiplied by 3. So in this case, then 3 multiplied by 2 is 6, divided by 4 multiplied by 3 is 12. In simplifying this, we will realize this is the same as a half. It's equals to a half. So that is what we can do in this regard. Okay. Now that was multiplication. Now we look at division of fractions. Suppose we have 4 over 5 divided by 1 over 5. Division of fractions. Now when we are dividing fractions, it's part of the slides in terms of the rules. When we are dividing fractions, we do not have to have same denominators. What we do is the division sign is turned into a multiplication sign, and the second fraction we write down the reciprocal, meaning we turn the fraction upside down. It will be 5 over 1. The first fraction remains the same, which was 4 over 5. So then that will then mean in the end we handle it the way that we handle multiplication. So it will be 4 multiplied by 5, which is 20, divided by 5 multiplied by 1, which is 5. And 20 divided by 5 is the same as 4. Others would go for a method called cancelling. You realize that 5 goes into itself once and it goes there once, and then even in the end you are just left with 4 or just 4 over 1. So that's in a nutshell how we deal with issues of fractions. On your screen, you will see the last question there, where we have this part D. We have 2 over 3 minus 2 over 5 divided by 3. Now I would want you to do this question on your own, but when doing this, we should think about something called BODMAS. BODMAS. What is BODMAS, and how does it advise us when we have problems to solve, where we have fractions and carrying different signs? Here we have a minus and there we have a division sign. So how would we then deal with that? Please solve that one on your own, and let's see what the answer will end up to be. So that was the fractions. The next aspect that is a prerequisite to us being successful in our assignment is algebraic expansion. We need to know important terminology when it comes to algebra. The first terminology is the terms. Now in algebra, terms are the things, are the numbers that you are adding or subtracting. Those are called terms in algebra. Not in English, but in algebra. Then we have what is referred to as like terms and unlike terms. Like terms are the terms that can be added or subtracted from one another. Like terms have the same variable, meaning they have the same letter raised to the same power, or they have the same exponent. So maybe we will understand this if we start doing a few activities. The coefficient is the number in front of the letter. The coefficient is the number in front of the letter. The index or the exponent is the number to which the power to which the specific term is raised. A variable is basically the letter within that, and then the constant is the number that stands alone. So now we will get to understand some of those terminologies as we proceed with our examples also. Now suppose we have the problem that is on the screen now, and the instruction is expand that algebraic expression and simplify where applicable. So now brackets in mathematics means multiply. Now to expand this, it means the number immediately in front of the bracket should be multiplied with all the terms, all the things that are inside the bracket. So we will have 2 multiplied by x, that produces 2x. And then we will have 2 multiplied by positive 7, and it will produce positive 14. So that is that algebraic expression expanded. We cannot add the 2x and the 14 because they are unlike terms. So for them to be like terms, there should be an x there, but it is not there. So therefore, we leave it as that. We do not add it any further. It does not become 16x. No, it will be wrong. So our expected answer is just 2x plus 14 because those are unlike terms. Let's look at another one. Suppose we are given 2y minus 3y plus, 2y minus 3 bracket y plus 3 close bracket. So suppose we are given that algebraic expression. What we need to do then is the negative 3 immediately in front of the bracket should be multiplied by the y, and it should also be multiplied by the 3 as a way of expanding, because brackets in mathematics means multiply. So that being the case, then we will have 2y as it was given. Negative 3 times positive y is negative 3y, and negative 3 multiplied by positive 3, it's negative 9. So that is the first line of expansion. Now I see that we have 2y and we have negative 3y and then negative 9. The 2y and the negative 3y are like terms. Those ones we can still simplify by saying 2y minus 3y. It produces negative y or minus y minus 9. So that is now us simplifying. First we expanded and we simplified by identifying the like terms and putting them together via the minus sign there. So 2 minus 3 gave us the negative y or negative 1y. And we don't usually write down the 1. The moment we write a negative y there, we know it's just 1y that is left there. If we look at the third example, we have 2 brackets within this expression such that we have 4 bracket 3s minus 2t close bracket minus 3 bracket s plus 3t. So we need to expand this one, and after expanding, depending on the terms that are generated, we might need to also do some simplification depending on whether or not we have like terms. So in this case then, it will be 4 multiplied by 3s. It will be 12s. And then we have 4 multiplied by negative 2t. It will be negative 8t or minus 8t. And then we have the negative 3 times letter S, it will be negative 3S. And then negative 3 multiplied by positive 3t, it will be positive 9t. So, as you see, I have 12 and negative 3s that are like terms there. At the same time, I have 8t and positive 9t that are like terms also. So then that will then generate a final answer of 12 minus 3s. 12 minus 3. So that is the first part that we have. 12 minus 3 producing 9, meaning it will be 9s. And then we have negative 8 plus 9t, it will be plus t. So our final answer will be 9s plus t for the given problem there. Again, as an activity for yourself, you should then try letter D. Letter D, we have 2 bracket p plus q, close bracket, minus bracket p minus q, close bracket. So try to expand that one and see what, and identify your like terms, put them together and see what your final answer would be also. So that was the algebraic expressions. Now we have to move on to another aspect that we will cover for today, and that is solving equations. Solving equations. That is what we are looking at. Now, maybe before we start looking at how to solve equations and so on, we need to understand the difference between an expression and an equation. An equation is a mathematical statement that equates, that tells us that one thing is equals to another. So with an expression, it's just an expression, there is no equal to sign. Whereas with equations, we find an equal to sign. So if we look at our screen, we will realize, for example, we have 3x minus 4 is equals to 8. Now, if we cover this aspect, that part there, and we are just left with 3x minus 4, that is just an expression. It's not an equation. But the moment we introduce the equal to sign, it becomes an equal to, an equation rather, and then we can solve. In terms of expressions, we cannot solve them, we can only simplify them. Whereas equations, we can solve them. So, now in this particular equation, we are told that 3x minus 4 is equals to 8, meaning we are looking for a number that when multiplied by 3 and 4 is subtracted from it, we get an answer of 8. So the question is, what was or what is that number? So in this case then it will be, now one way of solving it is to move all the numbers to the one side of the equal sign so that we are only left with the terms that have the variable. So now it was 3x minus 4. If we are to move the 4 across the equal to sign, the sign will change, it will become a plus. Or other people will say add 4 on both sides. It works out to be the same. So it will be 3x is equals to 8 plus 4. That is the starting point. But we know what 8 plus 4 is, so then we can just as well say this implies that 3x is equals to 12, because 8 plus 4 is 12. Now here we are multiplying, we want x on its own, so we divide by 3. It will be 12 divided by 3, which is then telling us that x is equals to 4. So then the solution will be 4. And we can always check whether that is true or not by going to the original equation and saying 3 multiplied by 4 is 12. And 12 minus 4 is 8. Then indeed that must or that should be the correct answer to that given problem. Sometimes we have unknowns on both sides of the equation. Now suppose we have 12y minus 48 and it is equal to 7y minus 13. 12y minus 48 equal to 7y minus 13. So what we need then to do is to take all the terms that involves the y's to the one side of the equal to sign and the numbers to the one side. Suppose then I will have 12y minus 7y, because the 7y was positive. If I take it across, it becomes minus, and this will be equals to negative 13. It stays where it was. Then 48, it was negative. If I take it across the equal to sign, it will be positive 48. So then we have 12 minus 7y, which will then be equals to negative 13 plus 48. So 12 minus 7 will produce 5, which means then 5y is equals to 48 minus 13, which is 39, no, rather 35. So y on its own then will be equals to 35 divided by 5, and that generates an answer of y being equals to 7. So that is how we solve that particular problem. Now, in this case, I would want you to practice or to try to put what you picked up with the two examples in trying to answer C, which is 19x minus 27 plus 7 equal to 8x plus 7x plus 12. What is the solution that would make the two statements to be equal? And finally, I would also want you to look at D, where we have to look at 3 minus 2 bracket y minus 2 close bracket equal to 10. So it is also another equation that I would want us to solve, because in solving those two equations, then we should be able to pick up the skills that we need in order to answer questions that are dealing with the solutions of equations or algebraic equations that are given to us. Now, the first part, we looked at solving algebraic equations when the equation is given. Sometimes we also have instances where the equation is not given, or rather we are given what is referred to as word problems. Then it is expected of us to formulate the equation ourselves, and then we then answer the question based on the equation that we formulated. So and usually in solving problems in mathematically, we have skills or strategies that we use. For example, making an equation, drawing a picture or a diagram to understand the words that are given to us. As we can just focus on the screen, rather on our board, then you will realize, for example, we might be told, or I might tell you that if I think of a number and then I multiply this number by 4 and then add 5, the answer I get is 8. Find this number. So yes, mathematically we should be able to represent the information that we have there. So it's a number. We can let this number be X or W or whatever, a letter of our choice. Then we are told that it will be W multiplied by 4, then 5 is added to give an answer of 8. We need to find that number. So it will be, multiply the number by 4, so it will be 4W if the number is W. Then add 5, meaning add 5, and the answer that we produce is 8. So that is what we are told. Multiply a number by 4, then add 5, the answer is 8. There it is. Now then, from here going forward, it's just a matter of solving this equation, because we wrote it now in algebraic terms for us to be able to solve it correctly. So, and this is a skill that we already picked up in the previous section that we looked at solving equations. So with this, then you can just continue to solve it. Suppose we are given another problem. We are told that John thinks of a number. Let that number be x. In this, he subtracts 3 from the number. So he thinks it's x. Suppose the number is x. He subtracts 3 from the number and doubles the answer that he gets. Okay? So then he you double that answer, and that answer that he produces will then be 12. So that is then the equation that we should formulate to indicate the story that we are being told there. And once we have the equation constructed, again, it's just a matter of expanding the brackets and then eventually solving it like we did, of course, in the previous section as well. So that is what I wanted to highlight in terms of the word problems. The next aspect that we need to look at is to just highlight a few of the laws of indices that we are expected to know in answering questions that are being captured in our assignment also. So in terms of the laws, I will only focus on 4 laws of the indices, and they are being projected on our screen right now. The first law of indices is on condition that the bases of the indices are the same. If we are multiplying, we can add the exponents. So if I have a to the power of m multiplied by a to the power of n, it will be a to the power of m plus n. So when we multiply, we add the exponents. That's basically what the law is telling us. And as examples, if we have 2 to the power of 2 times 2 to the power of 3, we know that it is the same as 2 to the power of 5 because we just added the 2 plus the 3 to give us that. So now, if we look at the second one, the base is b there, which is the same. So we can add the exponents of the b, the 3 plus the 4, that gives us b to the power of 7. However, the coefficients, the 2 and the 4, we multiply them the normal way. So that's the first law of indices that we need to look at and be able to deal with correctly. The second law of indices, it's about the division of indices provided the bases are the same. When we do a division where the bases are the same, we subtract the exponents, we minus the exponents. For example, 7 minus 3 gives us 4, and then we will have 5 to the power of 4. That is what we are having there in terms of the second law. The third law of indices, we are looking at, if we have brackets, brackets means multiply. So if I have brackets there, it will be mn, meaning m multiplied by n. So in this case, then it will be 2 times 3, which will then give me 8 to the power of 6. So in this instance, it's just a matter of making sure we know what the law is, and then we apply it accordingly. The fourth law is the zero index law, where we say any number raised to the power of 0 is equals to 1. So it's again a law, and within our book, or our study guide rather, we also have good examples and explanations as to how that law applies also. So that was the part on the indices that is being reflected in our assignments that we need to focus on in order to do well. Then we have aspects or issues of standard form. Now, in terms of standard form, we need to know what the standard form of a number is. And we should then be able to write numbers correctly in standard form, or numbers that are already in standard form, we should be able to give them in decimal notation. So, looking at the standard form of a number, by definition, a number is in standard form if you write it as A multiplied by 10 to the power of n, where A is a number between 1 and 9, 1 and 10, but n is an integer, is any whole number. So n is a whole number. So the restriction is on A. A should be a number between 1 and 10, but strictly less than 10. So, for example, if I have 2 times 10 to the power of 6, what we are looking there, it's a number that is correctly written in standard form, because 2 is between 1 and 10. Because 6, it's an integer, it's a whole number. It can be positive, it can be negative. So n should be an integer. Positive or negative, it does not matter. But it should be a whole number. If we look at, let's say, if I have 1.3 times 10 to the power of 1 over 2, this here that I just wrote is not correctly written in standard form, because this here is not an integer. So therefore, the exponent to which the 10 is raised should always be a whole number, and it should be positive or negative, and it can also be 0 as an integer also. So that's what is important. When we deal with numbers in standard form, the idea is for us to know what the standard form of a number is, and then to accordingly make sure that we apply the definition of a standard form whenever we are expected to write the numbers that are given in standard form. Again, we have aspects of area and volume that we are dealing with in terms of the assignment. Now, area, perimeter, and volume of basic shapes. For example, the triangle, the rectangle, and the square. So now if we focus on the screen, suppose we have the figure that I have drawn there, a triangle, in this case right-angled triangle, and I'm told the length here is 5, the length here is 4, and the length here is 7, perhaps not necessarily right-angled. So with that figure, I should be able to determine only the area as well as the perimeter, because volume is 3-dimensional, and then it should then be a triangular prism that I'm looking at. In terms of area of this, or rather, let's start with the perimeter. The perimeter is the length of sides, the total sum of the boundaries. So the perimeter will be equals to 5 plus 4 plus 7. The sum of all those will then give me the perimeter, because it is the sum of all the boundaries. Whereas the area, we have a formula of half base times height. So, and that will then be half multiplied by 4 multiplied by 5, and that then would then generate the area. Let's remember, in terms of area, suppose we are dealing with centimeters. The final answer for perimeter will just be centimeters. The final answer for area will be centimeters squared. And you need to show an understanding to that effect in your assignment. because if your units are not correctly indicated, you will then be penalized for that, for not showing the correct units. And the same goes for the volume. In terms of volume, it's three-dimensional, so then we will be talking about centimeter cubed instead of squared when we deal with the volumes. Going forward, I want to also highlight something important that is also being reflected in our assignment, and that is the theorem of Pythagoras. The theorem of Pythagoras is applicable to right-angled triangles. If one of the angles in the triangle is 90 degrees, then the theorem works. If it is not the case, then the theorem is not applicable. And it is used to determine the length of sides, especially in right-angled triangles. So, what does the theorem state? It says if we have a right-angled triangle, like the one drawn on the screen, and we are calling the longest side, the hypotenuse, we can call it H, and this side here we can call it A, and the side down here we can call it B. The theorem states that the height of the hypotenuse H squared is equals to the sum of the two other sides squared. So it will be equals to A squared plus B squared. And this is a very important fact that we can use to solve a lot of problems, including the questions that are within our assignment. So make it a point to revise this aspect also, so that you know exactly how to answer your questions that comes in your assignment relating to the theorem of Pythagoras. Finally, one of the important aspects that are also captured in our assignment is the issue of graphs. We should be able to plot points correctly on the coordinate system, and we should be able to answer questions that are based on pie charts or graphs that are drawn. Now, the grid on your display is an example of a graph paper, and we plot points based on where based on the scale that we are given. Now, suppose we have a grid that is given as the one that is on your display, and we are to draw two lines, one line that goes there and one that runs down there. And then we can label, let's say this is 1, 2. In terms of the scale, that's the scale that we are using. So, and this will be the x-axis, and that is our y-axis. Then this will be 1, 2, in negative, of course, in terms of the scale. And then down here it's 1, and then 2, negative, because of the scale that we are using. Now, one basic expectation is for us to correctly plot given points. Now, the points that we always plot it as coordinates that are given in the form of x and then y. Coordinates, it always represents the x value and then the y value, such that if I'm told plot the points 1, 2 as an example, the point 1, 2, it means then I go to the first value represents the y value. So I go to the x-axis. The first value represents the x-axis. So I go to the x-axis, I identify point 1. That's where 1 is, meaning along this line here. Anywhere along that line, that's where I find that point. Let's call this point point A. Along that line, in terms of x, somewhere along there, that's where it is. At the same time, if we look at the y coordinate, the second value, in terms of y, somewhere along the value 2, that's where that point is. So the point of intersection where the 1 here versus the 2 there meets, that's where point A is. I put a dot and accordingly I label it as A. Then I have correctly indicated in terms of x, point A is at 1, and in terms of y, point A is at 2. So that's the location of point A. Now suppose we have another point called point B, and point B is given by the coordinate -2, -1. So to plot point B, in terms of the x value, I need to get to -2. X-axis is there, -2 is there, so it's any value, it's along that line there. In terms of x, that's where point B is. And in terms of y, it should be at -1. So the exact location of point B, it will be a point that is down there. That's where point B is. And you usually put a dot and you indicate as such. Now sometimes the point, we don't need to plot it because it's already plotted, and then we are then expected to give the coordinates of the point. Suppose I have this point down here. It is being called point C, down there. In terms of our graph, it's there. Now the question is, write down the coordinates of point C, the coordinates. Then we will then say, okay, fine, I know that my coordinates of point C should be given first in terms of the number in line with which it is, in terms of x, and then in terms of y. So if we look at the x-axis, C is in line with the number 2. So then we write down 2. And in terms of the y-axis, which is those numbers there, it is in line with the number -2. So then those are then the coordinates of point C. 2, -2. So those are the coordinates of point C respectively. So in a nutshell, those are the key critical points that we need to remember and that we need to revise thoroughly as we are going through our assignment. For us to be successful in mathematics, we need to take time to study the content before trying to answer the questions. So it does not help us to rush into answering the questions if we do not have the correct content. So first study the whole course that you are doing, and then only try to start answering your assignment. Do not answer or do not study while answering your assignment. Rather study first and then you start answering the assignment as a way of illustrating or demonstrating your understanding of the work. And most important, maybe as a word of advice, try to do rough work, or your first attempt in answering the assignment, do it on a separate paper also before writing your final submission on your assignment papers. Because many a times, and most importantly also, we do not get marks if we do not answer certain sections of our assignment. It is expected of us to answer all the sections in the assignment. And again, my contact number as your tutor was displayed or will be displayed shortly on the screens also. Please feel free to contact me should you get stuck while doing your assignment. I'll not necessarily be able to give you the correct answer, but I should be able to guide you towards the thinking process or towards the part in the book or the resources that are there that you could consult in order to answer specific questions that you could be finding difficult to answer. Thank you very much. All the best of luck, in the completion of your 2018 assignment.